Hello, everyone. So today, this video is about just a quick review of the Chapter 6, Part 2, our mini test. And we're going to cover some things that we've talked about before and review for the AP test. And there might be some newer problems that come up that we haven't really discussed yet. So look at number 1. Consider the given function f of x equals x e to the negative x squared for all x values. Find the antiderivative. So another way to look at this is when they say find the antiderivative, what they're really asking us for is to take the antiderivative by using integration. So when I think about integration, I think of what we've done so far. Okay, is this something that is directly on my chart? No, it's not one of our quick answers. Is it algebra based? I can't factor anything out. And since those two don't work, usually U substitution is the next viable option. In this case, it is. So what I'm going to do is I'm going to let U, let me set up this integral. I want to find the antiderivative using U substitution. So I'm going to let U equal the innermost part, negative x squared. Then we're going to take the derivative of that. And I see that I do not have a negative 2 present in the rest of the integral, so I need to move that negative 2 over. But I do have the e and the dx. So U substitution allows me to say we're going to keep base e. I'm going to replace this top part with e to the u. And then the x dx is going to be replaced with negative 1/2 du. But that negative 1/2 is going to float out in front. So now the whole goal of U substitution, we made it easier. So whose derivative gives me e to the u? It's e to the u. The negative 1/2 is going to be a constant that just falls in as a multiplier. And then we have to put plus c. In the last step, we know what u is equal to. Replace u with the x, and there you go. All right, so if you didn't do that with the first one, go ahead and pause the video and try it with the second one. This one's just a little bit trickier. Nothing super crazy, but you notice it's a pretty big polynomial. So I'm going to take the largest innermost part and try that for my u. So when I take the derivative, I get 6x plus 12. Now you'll notice something here. My du, okay, so I have the dx here. That's going to take care of that part. But I don't have exactly what I need, x plus 2, but I have something close to that. What if I divide a factor of 6 over here? So if I divide by 6, both sides, and I can put this in parentheses, notice I have exactly what I need right here. So if you're a highlighted person, there's my u. My du is going to take place or replace the x plus 2 dx, and all that's left then are my bounds. Now this one does have bounds, so we have to evaluate the bounds in terms of the u that we had right here. So what if I take 1 and plug 1 in here, here, and here? You don't have to show this work. You can do this all in your head. But if I evaluate the upper limit, I get 3 plus 12 plus 1. Well, that's 15, 16. Okay? And then what if I evaluate 0? Right? We got to evaluate both the upper and lower bound. Well, if I plug in 0 here, here, and here, all that's left with is a positive 1. So this allows me, all of this allows me to rewrite my integral with the new bounds from 16 to 1. And now I'm going to replace the yellow with u. Actually, I want that to be green. And then we just have to make sure that du, 1/6 du, is going to replace the two green highlighted x plus 2 dx. So the 1/6 is a multiplier. That's going to float out front. And then I have du, a much, much simpler integral to evaluate. So now, what do? We're going to anti-differentiation. We're going to add 1 to the top. So this becomes u to the 3/2 power. But if I put a 3/2 up front, we got to multiply by the reciprocal. And then just don't forget, this 1/6 is still part of our multiplier. And then we evaluate this from 16 to 1. Okay. So what I'm going to do then is I'm just going to multiply. Actually, I think I'm going to reduce a factor out here. This will reduce out and be 1/3. So 1/9 is now my new multiplier. And then I'm going to multiply that at the end, but I have 16 to the 3/2 minus 1 to the 3/2. And hopefully you're really comfortable with this. I think of 16 to the 3/2 the same as the divide by 2 is like the square root. And then we've got the power of 3. Same thing here. I mean, it's a 1, so really you don't need to show any of this work. Square root of 1 is 1, 1 to the third power, that's minus 1. But 16, square root of 16 is 4. 4 to the third power is 64. And then just don't forget your 1/9 is going to drop down. So 63 times 1/9, or 63 divided by 9, gives me my final answer as 7. Okay, so to review, think of this as just your checklist, right? If you can use the antiderivative chart, you're done. If that doesn't work, I always try algebra, like factoring or dividing something out. If that doesn't work, we usually rely on u substitution. If those three don't work, then we have the new material we learned the other day, long division and completing the square. So this is the page that we talked about from your textbook, page 439. These are your facts. This is your chart. If you see it on there, you're good to go. And we did a couple of these problems in later examples. What I wanted to do is show you an AP style question. This is kind of like a portion of a free response question that has us go through and kind of use our knowledge, but along with some context. A particle moves along the x-axis in such a way that its acceleration at time t, when t is greater than or equal to 0, is given by a of t equals 4 cosine 2t. And then they know, or they tell us, at time 0, the particle has a velocity of 1. So we have to write the equation for velocity. Well, I have the acceleration. I need to undo acceleration, and the only way to do that is to take the antiderivative of the acceleration with respect to time. And if I do that, that will give me the velocity equation. So we know what that equation is. And you might think, well, we've already done problems like this. And you're right, we have. We haven't done one where you are supposed to use u substitution, though. So that's where the new material is applied in. Well, if I have the antiderivative, this 4 can actually float to the outside because that's just a multiplier, right? So now I have the antiderivative of cosine of 2t. Well, in this case, I'm going to let u equal 2t, and the derivative of that is 2 dt. But I don't have an extra 2. You could creatively get one, but in this case, I would just move the 2 over. And now I have an integral. I'm going to make this black just so it kind of stays with my color pattern. So what do we have? We've got cosine of u, and then the dt is going to be replaced by 1/2, which is a multiplier, so I'll pull that out. du, excuse me. Now this antiderivative is much friendlier, right? 4 times 1/2 is 2. Whose derivative gives me cosine? It's sine of u But now, again, I don't have to put u because I know what u is equal to. So I'm going to just replace that right away. The thing you do have to be careful with is you have to put plus c. Now, this is not the specific equation. This is a general equation. We want to write the equation of the velocity of the particle given an initial condition. So now, just like we did in the last unit, remember this is 0, this is 1, so this is t, this is v of t. What happens when I plug in 0 for t? We can actually find that specific c value that we're looking for. Okay, well, v of 0, that is equal to 1. So v of 0 is 1. 2 times the sine of 0 plus, and actually I'm going to make this a red c just to keep it the same. Well, we know that the sine of 0 is 0. So 2 times 0 is 0, which means c is equal to 1. And then my final answer is, what is the velocity equation? The particular solution is when you take this value of c and rewrite it into the original problem. There you go. Now, good news is the next unit, we're going to be revisiting this. So we're going to get more and more practice with that. But you can see how the material we just learned, use substitution, is applied within this. All right, this next problem, and again, I hope you're pressing pause on these to watch them and try them on your own. And then you're going to watch them to check your answers. All right, well, what do we got here? 2 parts. So the figure below shows the graph is continuous. It's a function of f. This is the graph of f. And the regions A, B, C, and D, and E have the respectful areas. However, they don't tell you which ones are positive or negative. You have to look at that from your graph. So part 1 just says find the integral. Notice this has nothing to do with this graph. There is no f here. So we're just finding the antiderivative. I'm going to add 1 up top. So if this is 2x, I'm going to add 1 up here. So if I have 2x and I put a 2 up top, that means I have to divide by a 2. And then if I have 16, the antiderivative of 16 is 16x plus c. And in this case, the 2's would reduce out. And I get x squared plus 16 plus c. Now you could take the derivative of this and see that you get back right where you started. All right, part 2 is a 2-part, well, not a 2-part, it's a multi-step problem, but you have bounds now. And now we deal with f, so we're going to have to refer back to this graph at some point. What do we know? We know that we don't have a 2x plus 16 in this whole mess. So I want to get rid of that using use substitution. We're going to make this easier to identify. So then I want to go from -7 to 5, -5 of f of u, because we're replacing this with u, and then du is the derivative of u, which is just 2 dx. But I don't have an extra 2 represented, so we have to move the 2 over. And that 1/2 just becomes a multiplier. All right, now I made a tiny mistake here, and maybe you identified it. I got too excited. I accidentally wrote the bounds in. There's a problem with those bounds. Those bounds are written in terms of x. I need them written in terms of u. So I'm going to plug a -5 in here. And you can do that in your head. -5 times 2 is -10. -10 plus 16 is +6. What if I plug in -7? -7 times 2 is -14. -14 plus 16 is 2. So I have new bounds from 2 to 6. And now we have to really understand, what is this asking? how do I take the antiderivative of f if I don't know what it is? That's where we understand the meaning of this. From 2 to 6, I want the area under the curve. So from 2 to 6, this whole area is negative, and it's d. So 1, 2, 3, 4. 1, 2, 3, 4. Here's what it is. D, they tell me in the directions, has an area of 5. However, it's below the x-axis, so I'm thinking that is equal to negative 5. And then we just can't forget about our multiplier, 1/2. So the answer to part 2, this integral, is actually equal to negative 5 halves. All right, one last one. So this is kind of dealing with our integration. We have to evaluate the integral. Which method of integration should we use? Well, hopefully you're going to pause this and work through it. Let's look through this. This is definitely not one of our charts. Algebra, if I could try to factor the top and factor the bottom and see if they have any common factors, we'd do that. Now I should say, algebra is technically the same thing as long division. So that gives you a little clue on what we're going to do. But u substitution isn't going to work either, because if I take the top part to be u, I'll get a dx up top and an x on it, but this x plus 2 is on the bottom. So u substitution actually does not work in this present form. So that means we have to do long division. Okay, so I'm going to take the numerator and see how many times the denominator goes into that. So I'm going to multiply by, I want this value to look like 3x squared, so I have to multiply by 3x. So I get 3x squared plus 6x, and then we always add the opposite to make those the opposite signs and add. All right, when I do that, those values reduce out, and I'm left with negative 4 plus 1. And then I have to start all over. Now I want to take this x and make it look like the new value, which is negative 4. So I'm going to multiply by negative 4 to both spots. And then we add the opposite. So that changes the signs. And then I can add them together and I'm left with 9. So remember, long division just allows us to rewrite this integral, negative 1 to 1. And my answer is, I can't say my answer, but my new form of this original integral is 3x minus 4 plus 9 over x plus 2 dx. Now you'd have to be very careful because we have to integrate and we have bounds here. So I'm going to take the antiderivative of each piece. This antiderivative is already a 1 there, so if I add 1 to it, I'll get an x squared. Now the 3 is there, but I have to then divide by 2. The antiderivative of negative 4 is negative 4x. And if you can't do this one in your head, then maybe you want to split this one off and do it separately. Now if I do that, I have to be careful because I evaluated these two already. So they have to have the bounds from 1 to negative 1. And if I do this one separately, then I can rewrite this. Now you might already know this in your head because we've done it enough. In that case, you can skip this step. But I'm going to pull the 9 out front. There's a 1 here, and I got x plus 2 in the bottom. So my last step then would be to let u equal x plus 2. In that case, du is equal to dx. And we get 1 over u du evaluated from, now we do have to change the bounds on this one, and that's the important part. If I change the bounds, this 1 is going to go in here, and 1 plus 1 is 3. Negative 1 goes in here, and negative 1 plus 2 is 1. So then I can take the antiderivative, which gives me 9 natural log of 3, natural log of u, and then we're going to evaluate that from 3 to 1. So 9 ln of 3 minus 9 ln of 1. Notice the absolute value bar is important there. And we got to then do the same thing here. I have to now evaluate this at 1 and at -1. So I'll do the first part by plugging 1 into each x, and then I'm going to subtract by plugging -1 in. Tight squeeze, I don't love that. But let's simplify. 1, so that's 3/2 minus 4. And this will be a positive 1, so 3/2, and this will be a plus 4. Now you might notice, before I combine anything, you might notice something's going to happen here because we've got the subtraction of both terms. So I'm going to make this an addition and add the opposite. The nice thing about this is notice 3/2 plus -3/2, those go away. And I get -4, which is -8. So then this drops down. Now you'll notice that isn't one of my answers. It's close, but something goes away. And it's this part right here. We do have to know that the natural log of 1 is 0. So this whole thing is 0, which means my final answer is -8 plus 9 times the absolute value, or that natural log of 3, and I can write this as a positive 3 because if I use the absolute value, that turns into just a 3, and the answer is C. Okay, so what do we got? Quick reminder, if you didn't pay for the AP exam, do that before Sunday. Don't wait until the last minute, because if something goes wrong, no one can help you. Okay, figure it out today. And then Chapter 6 test, Part 2 is assigned officially today. You could start it if you want, and then go through, and it has to be due by Sunday, the 28th at 3. It is, you get 5 points for submitting your solutions to Schoology. It's 22 points total. There's 4 multiple choice questions, 2 uploads. We're going to do U substitution with and without limits, and long division. There will be no completing the square on this test. Good luck.